are doing 15D, Identities in Pascal's triangle. We're not really doing many new things today, but perhaps some harder types of questions of the things that we've already done. So we're going to go straight to our examples. First of all, we want to prove that NCR is equal to NCN minus R. So if I start with the left-hand side, NCR, we have the formula for that on your formula sheet. It's n factorial on the top, r factorial on the bottom, and then we subtract the n and the r to be n minus r factorial. Now, if we go to the right-hand side, we want to find out what NCN minus r is equal to. Now, using that formula, the n up the top here means I have an n factorial on the top. The n minus r will be first, factorial, and then I want to subtract n and n minus r, which will be n minus n, and I also want to subtract the minus r, which means it changes the sign to become a plus r factorial. Now, n minus n in that second bracket will cancel out. So what I have is n factorial on the top. The second bracket is just an r now, so that's going to be an r factorial times n minus r factorial, which is exactly the same as what I had over here. So that is equal to my left-hand side. So therefore, I've shown that my left-hand side is equal to my right-hand side. Question 2 is a slightly more complicated version of that. I want to prove that NCR is equal to n minus 1 CR minus 1 plus n minus 1 CR. So we already know what NCR is. Let's start with the right-hand side of the equation and simplify that all down, and hopefully we will come out with NCR again. So that's the right-hand side. Using the combination formula, the n minus 1 is going to go on the top, n minus 1 factorial. The r minus 1 is going to be the first bracket, factorial, and then the second bracket is subtracting that one minus that one. So that would be n minus r and plus 1. Remember that minus sign expands through, factorial. Now, we do have a minus 1 plus 1 in there that will cancel out. For the second one, the n minus 1 factorial will go to the top. On the bottom, I'm going to have r factorial, and then subtracting these, I will get n minus 1 minus r factorial. I'm just going to rewrite that slightly tidied up. So n minus 1 factorial on the top, r minus 1 factorial, and n minus r factorial for the bottom because the one's cancelled out, n minus 1 factorial over r factorial. N, now I'm going to switch the order here to be n minus r minus 1 factorial. Now, looking at the denominators, the r minus 1 factorial and the r factorial are very similar. If I unroll the r factorial, I would get, so for the second fraction, I'm going to get r times r minus 1 factorial. Okay, so I'm just going to unroll for that second fraction. The n minus r factorial, these ones, they're very similar. The second one with the minus 1 on it, it is smaller, so I can unroll that first one to be n minus r times n minus r minus 1 factorial. Don't need to unroll this one. Okay, I haven't changed anything on the numerators yet. So I want to get a big common denominator. From the first fraction, remember my color coding here, the r minus 1 factorial and the r times r minus 1 factorial, they go together. But my first fraction doesn't have the r. So I'm going to have to multiply the r to the top which will be r times n minus 1 factorial. I'm going to need both the r and the r take 1 factorial on the bottom. I'm also going to need both of those brackets on the bottom, which is n minus r times n minus r minus 1 factorial. Now the second fraction, however, did not have the n minus r at the front, so I'm going to need to multiply that to the top as well. So that will be plus n minus r n minus 1 factorial. Now, I don't want to expand the top, rather I want to factorize it further. What I want to do is take out the common factor of n minus 1 factorial. So this is my common factor. And I want to put the leftover parts into a second bracket. So the r and the n minus r go into a second bracket. On the bottom, I can roll those factorials back up. So r times r minus 1 factorial would just be r factorial. And n minus r times n minus r minus 1 factorial is going to roll back up to be n minus r factorial. Now on the top, r take away r cancels out. So all I have is an n in that bracket, and n times with n minus 1 factorial is going to be n factorial over r factorial n minus r factorial. Now that is our formula for NCR, which is the left-hand side that we were trying to show way up here. So that's equal to the left-hand side, and we have proven it. On the next page, there's a couple of tricky questions here that I wanted to show you. It says we want to find the kth term. Now, last lesson I gave you a formula to find the term, which was this one over here. NCK, x to the power of n minus k, and y to the power of k. Now, it worked great when I said to find the x squared term, because we worked out what the powers were that needed to go in what places. But when I ask you for the kth term, because in an expansion, so let me use the example of something to the power of 4. So if I was expanding 1 plus x to the power of 4, the coefficients I would get from that are 1, 4, 6, 4, 1, which we know from Pascal's triangle, but using the combinations, that's 4C0, 4C1, 4C2, 4C3, and 4C4. If I was asking you to find the first term, the first term is 4C0. This, where that k is, would need to be a 0. But I'm asking you for the first term, which is one bigger than that. So if there's a k here, it means it's the term k plus 1. So you'll need to write that down, knowing that that one is always going to be one larger. So when I'm trying to do my question, if I'm trying to find the kth term, so I want t to the k, that means I'm actually going to need one less in here for the bottom of my combination. The n on the top is always this power here, so the power that I have is n plus 1. C, and the k down here, as I said, is 1 less than what is on my term, so it's going to be k take away 1. Then we know we're going to have something happening to our first position, so my first position in this case is a 1, and the second position is an x, and I need to work out the powers for each of those. The x, the second position, is always the easiest. Whatever's on the bottom of this combination is going to be the same as the power up here, so that's going to be k minus 1. To work out the power of the first position, you need to subtract these things here on your combination. So it's going to be n plus 1 minus k, and don't forget to expand the minus through, plus 1. Now that does become n plus k plus 2, but 1 to the power of anything is always going to be equal to 1. So this part here is not actually going to do anything in my term. So my more simplified answer would be n plus 1 ck minus 1. I don't need that part highlighted in yellow. I just need the x to the power of k minus 1. All right, part B, let's practice that again. I now want to find the kth term of this expression. So kth term means t with a little k there. Using my formula, the power up here is going to be on the top of my combination. So 2n plus 1 c, and the bottom number is always 1 less than this. So it's k take away 1. Then I have first position and second position. The x is going to have the same as this k minus 1, so that's going to go up there. The power of 1 is going to be subtracting these two parts here. So it'll be 2n plus 1 minus k plus 1. Again, 1 to the power of anything, even if it's messy like that, is always going to be equal to 1. So the simplified answer is going to be 2n plus 1 ck minus 1, x to the power of k minus 1. And that would be the expression for the kth term. Your practice is on the next page.